In this presentation, we'll be talking about how CAD facilities layouts can become enterprise decision-making tools. I'm Mike Jolliker. I'm the director of the Autodesk relationship at ProModel, which is a division of BigBear.ai. In this class, if you will, we're going to be talking about the following things. So we want to see how an ROI can be developed from the data gathered from a simulation. We want to understand how discrete event simulation and space planning are tied together to help customers do things more profitably, lower costs, and be more efficient. Be able to provide strong metrics to support a business case, and provide both 2D and 3D animated process models utilizing AutoCAD Inventor and Forge with one click, and also using the ProModel AutoCAD Edition to help facilitate that. So, discrete event simulation is not new. It's a valuable tool for validation. It's been around in one form or another since Henry Ford rolled the first Model Ts off of the line. In fact, ProModel has been delivering PC-based simulation solutions for over 30 years to thousands of customers worldwide. Discrete event simulation inside of AutoCAD, however, is new. The ProModel consulting team will tell you over 95% of projects they delivered started with an AutoCAD layout. A lot of effort had to be expended to utilize a drawing in the ProModel environment and in any other discrete event tool really that's out there in software. So for that reason, ProModel and Autodesk teamed up to provide an easy-to-use, efficient tool set that runs inside of the AutoCAD you use today for layout. This new tool set helps build the foundation of an integrated factory model that is much more than a drawing that represents space claim. The CAD model now becomes a powerful enterprise decision-making tool. Employing the entire workflow across the entire team has many benefits, but we'll highlight these three in this presentation. Utilizing the Autodesk Factory Design utilities within the Autodesk Product Design and Manufacturing series allows users to rapidly create both 2D and 3D representations of their ideas. ProModel AutoCAD Edition allows the ability to add another layer of benefit, the ability to validate if your design will meet your production needs at the lowest cost. Combined, this is a tool set that is easy to learn and provides more value to your current AutoCAD layout workflow. There are many factors to consider when planning. One of them is variability in a process. The reality is, what you think is the case many times isn't. Better, more reliable data is the key to success. Spreadsheets can't provide this. They have no understanding of variability or the concept of time. Let's face it, manufacturing processes are complex. There are many factors to consider when planning, and sometimes it can be as simple as adding more buffer into the system in key areas to reduce process sensitivity, or as complex as validating if adding automation to a line will not only solve the issues but pay for itself in a short period of time. Again, better, more reliable data is one of the keys to success. The tools in the factory design utilities excel in helping customers avoid excessive cost and risk in changeover. That is making sure everything will physically fit into the space allotted and that the equipment interfaces physically as well. This helps avoid change orders on installation, which can help drive project costs up substantially. What it does not do is allow planners to see how this planned change will affect the cost of the products being manufactured or the ability to confirm that the design will meet the required throughput to meet demand, both in the current frame and also in the future. That's where the ProModel tools come in. We allow those that plan change, be it for new products, process improvement or automation, or bringing acquired companies into the corporate fold, to fully understand if the process that is being designed will meet the production needs and be cost effective, either lowering the cost of manufacturing or allowing more manufacturing agility. The combination of these tool sets allow customers to build out facilities digital twin that can be used over and over again to test ideas before committing any capital. The Autodesk ProModel solution reduces cost and risk not only for installation of the new process, but operational risks for producing the product throughout its life cycle. Here's a brief overview of the user interface. A straightforward, easy to navigate interface makes the tool easy for new users to master quickly and experienced users to be able to apply macros, logic, and other advanced tools easily to further refine the simulation outcomes. Any AutoCAD user will find this easy to use. A tab is added to the AutoCAD ribbon containing all the command structure necessary to create simulations. Browser panels provide detailed information and interactive feedback in regards to the simulation being studied. Let's provide a quick demonstration here. What we're going to do here is show you how easy it is to build a model from an existing AutoCAD drawing. So in this demonstration, as I said, we're going to show how easy it is to streamline your layout process and ensure design confidence in manufacturing process design. We have a representation of a proposed new manufacturing area in AutoCAD. The AutoCAD blocks that are in the drawing here represent a basic footprint of some CNC and washing equipment we require to manufacture our new part. The Pro Model interface consists of a tab on the ribbon bar and panels that act as a browser for the manufacturing process. So we're going to add locations by simply picking the blocks, and Pro Model now understands that these are stations where processes will occur. We're also going to add an entity. So the entity is the part or assembly that's going to be processed through the system. So we can handle multiple products through here, but for this demonstration, we're going to show it with just one part. We can add initial costing for that part, and because this is in AutoCAD, we can provide a size envelope for our part as well as a basic shape. In other words, we can use a simple graphical representation, or we can use an AutoCAD block to represent our part. Once we have these process elements, we can now assign a flow of the part through the system. We're simply going to select in the order that we want the part to flow. Once we give it a flow name, we can now choose the exact path that we want the part to follow in its processing. So first we'll select the CNC machine, then the parts washer, then the 5-axis machine that it's going to go to, and then the other part washer, and we'll exit the system from here. So we're going to take a look at the process sheet that defines the equipment that we want to use. The industrial engineer was kind enough to supply us with that information. And we can now see that he has a few machines in mind. He's going to use a Chiron to do the 5-axis milling and some parts washers. So we're going to assign times to these. In this case, we can either go with a static time or we can use what's called a distribution to be able to accomplish this. So we can choose mathematical average. We can use logarithmic. And normal, uniform, you name it, we can do that. So in this case, we're just going to put in a static value so we can get a basic idea of how our system's going to run. We can always go back in later and change these values as we need to. So let's go ahead and simulate our very simple simulation that we have here. So we just click the Pro Model Run button, and we can now see our simulation running. We can see where the part is going through the cycles and where it needs to go. And we also can control the clock speed. In other words, we can speed up or slow down time to be able to understand better what's going on. And the little clock up in the right-hand corner tells us exactly where we are in our process. From here, we get a dashboard that tells us all kinds of information, completely configurable dashboard. It's telling us now that the basic system allows us 477 parts in our specified time. So we're ready now to make something look a little more accurate. So we're going to utilize the factory design utilities and put in some machines, the real machines that represent those spaces, the charons that our industrial engineer had specified. In addition, we're going to put in parts washers. And again, using the factory design utility library, I can do a Boolean search for an industrial washer, and it brings me back all of the ones that could fit and allows me to be able to select what I need. I'm going to take this one and rotate it around so that it's actually facing in the right direction. And you'll notice too, if we move one of these objects, so if I just grab onto this and move it out of the way, that the flow lines stay attached. So the idea here is that we are going to make sure that things as updated continue to update so we don't make any mistakes or have any issues. Now these machines are actually set apart from each other because there's a pit in the floor. So we need to connect those two machines together, or at least connect the process. So what we're going to do is use the factory design utilities from Autodesk to allow us to put some conveyors into place. So we're going to select from one of the 2,500 standard objects that's in that library and place that in there. And you'll notice too, as I put these together, you see how they kind of act like magnets and they snap together. Well, that's because the factory design utilities understand that. The idea is for people to be able to create layouts rapidly using standardized shapes. So it makes it very easy to put that in there. So now we have the conveyor. We're going to tell ProModel that these objects represent a conveyor. ProModel is smart enough to know what conveyor objects are. If we selected other objects in there, it would ignore them. So it now needs to know the direction that it's going to flow, and then we could do things such as controlling speed for the conveyors if we needed to. We're going to add in the two ball transfer tables as stations. That's where we're going to be putting the parts to be able to put them on the conveyor and also to be able to queue them to take them off the conveyor. To add them to the flow is as simple as a right click inside of the browser, and we simply select where we want our parts to go next. So in this case, we're going to go from the ball transfer table to the conveyor. We'll go ahead and add in that other ball transfer table into the flow as well. Simple right click. And then finally, what we'll do is we're going to take our new conveyor system and tie it into our flow by going from the ball transfer table to the CNC machine, the second one. So we now have a completed flow with a conveyor in it. So if we rerun again, we're going to see a different behavior. We can also open our model inside of Inventor to be able to get a 3D view. So not only is there the benefit of being able to view in 3D, but we can create drawing views very easily, pretty much any drawing view that we need to help facilitate installation of this equipment. So again, the CAD model is not only for the simulation, but also for all of the documentation of the process as well. From here, single one button click allows us to be able to animate the same thing you saw in 2D, now in 3D. Again, one button click. There is no product in the market that is easier than this. So very easy to be able to get this. We go from 2D to 3D to be able to simulate in 3D. We also have the dashboard information. You'll notice now that there's only 332 parts coming out compared to the 377 we had before. Well, that's because we put the conveyor in there now, and judging on the conveyor speeds and the extra motion, it does take more time. So we can go in here now and completely configure this dashboard any way we want it. So in this case, we'll add in the cost. And this is the overall cost that's being calculated through that shift, how much it's going to cost to make the number of parts over that shift. So very quickly, we can get to an answer in a matter of minutes. So this is just a very easy way to get a rough idea or a rough guess of what our throughput's going to be. So let's take that a little bit further. So we're going to add a small line change. As we know, the only constant in engineering is change. So as we kind of mature our layout, there are going to be things that are going to change in it. It could be positional changes in machines. It could be additional equipment that's going to be added, which is going to be the case here. So again, we have our baseline. We're saying that our baseline is we have to get 300 parts out in a 40-hour shift. So we can see now that we've added more information to this model. You'll notice too that there are people, which are known as resources inside of the model now, which are actually performing the tasks to create the parts. They're also moving the parts from place to place. And again, things like the walk speed, the amount of dwell time, all of those kinds of things are taken into consideration. And we can see now that we do have more than 300 a shift, and we're good, and we're utilizing our worker at about 60%, which is also really good. But we share this with the greater team, and our industrial engineer came and took a look at it, and he said, you know, what we really need to do, though, is we need to add another station here. We found in the past that by adding an inspection station here, we're able to drive down a lot of the bad parts that are coming out, right? We catch them early in the process. Sounds like a pretty good idea. So let's take a look at that. So first thing we're going to do inside of the inventor environment provided by the factory design utilities is we'll place some objects in here. So the workflow is very similar to what you would do in 2D, and the system is smart enough to understand things like the floor and how to behave accordingly. So it makes it easy for new users that aren't used to working in 3D to be able to accomplish these tasks. So we'll go ahead and slide that inspection station around on the table to make it fit. And because these objects are parametric, we can go ahead and change their size in place very easily. So again, just eliminates a lot of extra work. Imagine how long that would take you inside of AutoCAD to make all of those changes like that. Let's go ahead and add a couple of bins because we have to have a bin for our good parts and a bin for our rejected or not to spec parts. So we'll add those as well. You'll notice now that when we open it again in AutoCAD, it automatically updates, making sure that we don't have anything that is missed in our design. So once we have this equipment in place, we can now simply adjust the flow to take it into consideration. So in this case, we're going to add a route that goes to this inspection machine, and then we're going to add two routes, one going to the reject parts and one going to the good parts. Rather than going first available on these, we're going to set a percentage. We're going to say that 90% of the parts are good parts and 10% are bad parts. Now, we do have the ability to use distributions in here as well, so we can build variability into that. But for right now, we'll just keep those as static numbers. So we've got those in. The other thing we need to do is assign our worker to that. So in other words, the worker on the right end of the line now not only has to do the machining of the parts and the moving of the parts, but is also responsible for the inspection of the parts too. And we can see already that this person is jumping all over the place. So they're moving from place to place. They're spending a lot of time in transit to be able to do work. And we're also seeing that parts are backing up. We also saw that there are only 201 parts that came out of the system, 229 in total. So again, this does definitely affect our throughput. So we need to be able to make a change. Remember, our minimum throughput was 300 parts for this shift. So we need to make a change. So we're going to use the scenario manager. So the scenario manager allows us to try different options and ideas for our to try and solve the problem of throughput. Now we can have as many of these as we want, and we can use whatever parameters are available inside of that model. So those could be variables that we've created, but it could also be just the regular parameters of those machines. So the first thing that we're going to do is we're just going to add a person. We'll just make it very simple that way. So as we can see here, we've got now, instead of one person in the scenario, we've got two people that are processing. And you'll notice too that one of the people is spending most of their time next to the inspection station. That makes sense because it takes a long time to inspect. So here's our baseline as we saw before, and now we can see if we add the two operators, we can look at these and compare them against each other. We can see that we're now able to get 305 parts out, and that our second worker is not nearly as busy as they were before. So this might be a good solution for us. Again, we can see this again in 3D. This allows us to be able to show this design idea to people that probably aren't used to looking at 2D drawings or understanding. Because this is in the Autodesk Forge environment, it allows us to be able to zoom around, to be able to rotate, all these types of things that allow us to be able to better understand what's occurring inside of our simulation. So let's recap this. As we can see, we're able to validate the space claim in 2D and 3D. We're also validated that our line will be able to meet our production needs for throughput. Remember, we had to get 300. We're getting more than 300, which is good. we also are validating too that we have the correct number of people required to efficiently run the line, and we can also apply things such as costing to those people, so we can get a good understanding of how this is going to affect our cost per part. This is going to provide confidence that the investment made in the equipment will pay itself back in short order. Moreover, you can reuse this simulation over and over again to test different scenarios, process changes, or new processes based on this process. Let's shift gears a little bit. ProModel is not only used for discrete manufacturing, it can be used for just about anything. In this case, we're going to be talking about warehouse models, but we could use this for retail. We could use this for just people studies of how they would move through a space, for example. So all of this information can be done very easily inside of the ProModel environment. So in this example, the customer is looking to validate truck unloading. So what it is they have snowblowers and tractors that they have to unload in a 10-hour shift. As we can see, the layout consists of the factory design utility assets representing the racks, as well as a fork truck that's going to do the unloading tasks. So in this case, we're going to create the product flows right inside the AutoCAD drawing that represents the proposed layout. So ProModel has a very easy to use interface that allows us to rapidly create the simulation. So first thing we're going to do is add our locations. So we'll go ahead and drop these in there. In this case, these are the spots that are on the racks where we're going to be putting our tractors and our snowblowers. So we'll just simply grab those. And as you can see, very simple user interface to be able to find this. So we'll turn on our browser here and we'll start adding that information. We can use the add button or simply right click to be able to get to this. We have the entities, flows, resources, and path networks available to us as well. So in this case, we're just going to start selecting these locations. We'll do them one at a time to begin. So we can select here, this is our first location, and we see location 1 appears in our browser. So now what I want to do is grab more than one at a time. So in this case, I'm going to grab a window using the AutoCAD window command. I can now grab a whole bunch of these. So we're going to grab them, and you'll notice they follow the direction too that I picked. So in this case now, we're able to see exactly which location is there. And you'll notice too, anything that we highlight in the simulation browser highlights also in the graphics window. So it makes it easy for us to understand. We also need to add capacity to these. So we're going to say that each shelf can hold 4 of the objects. And we're going to put a counter on each one of those too, so we can see how the racks are filling up as we work. So we'll go ahead and add a bunch more. So we're going to go ahead and pick all the other ones that we need and drop those in there. So we'll just kind of move ahead from that. The next thing we need to do is put in a path network. So this is going to be the path that the fork truck is going to follow when it's doing its drop off and pickup of the objects. So we've got one single line in here representing each of the spots where the fork truck would turn. And just using an AutoCAD command of copy, we're now going to take that same thing and put it in each of these aisles. So again, you don't have to just draw it in all at once. You can utilize AutoCAD commands that you've been using since the beginning of time. And then we'll connect those endpoints together. So that way we know that the fork truck has to follow these paths and it won't crash through one of the racks. So now that we've got these, we've got the one for tractors and snowblowers. We now need to add the flows for these. So we'll go ahead and add these in there. So in this case, we're just going to select where things are going to go and how things are going to happen. So we're going to call this flow tractor unload, and we're going to select the tractors. We could select all of the objects, but in this case, we want to be specific, and we're going to grab just those tractors and move those over accordingly. So now that we have that, we simply tell ProModel where we want the path to go. So in this case, it's starting at the truck, going to a staging area, and then from there, it's going to the rack. So we're going to start at this end, and then we'll start working our way back. So it's just a matter of lather, rinse, repeat. We'll add another location as we go, and we can say add another route. So we're just going to keep picking these. So we're going to go from that location, which is the staging area, to each of the areas on the racks. So we'll go ahead and add those in there as we need to. So we'll go ahead and pull them in, and we can see where everything goes. So now that we've got those locations in, We can see where everything is. We can see the flow of where the tractors go. And in this case, we've also added in the snow blowers as well. So they're going to go to a different set of racks. So we can see where the flows are as the crow flies, so we can see the distance as they go. And remember that these are going to be following the path that the fork truck uses. So again, we're just looking where things go, but the fork truck is going to control the path of how that's going to get there. So now that we have that, we can assign that fork truck to that path network that we have, and that's how it's going to follow to deposit its stuff. The forklift truck also, we can control its speed, its acceleration, and its pickup time very easily. So we can drop that in too. We can also use things such as macros that will allow us to be able to go in and change or turn these dials very easily, all from one simple spot. So we'll go ahead now and simulate this, and we'll start seeing things run. As we can see, the fork truck is now picking up the objects, the tractors, and bringing them down and putting them on the shelves. We can see too, as we zoom in here, that we're able to start seeing how many are being on the shelves and how many are coming out of the truck. So in this case, we can see that the amount here is decrementing, that we're taking those out of the truck and getting them placed, but also we can see that these are incrementing. So we're adding these to each of the racks, and as it fills up a rack, it simply goes to the next rack, right? So that was the capacity of that rack is only 4. So when I'm done, go to the next rack and fill that one. Now we can configure this any way we want to. Again, I kept this just fairly simple for demonstration purposes, but we can use all kinds of different parameters here to be able to fill the racks. But we can see if we look at the clock in the upper right-hand corner, we're at over 6 hours right now, and we still haven't unloaded all of the tractors. So that's telling us that we're probably not going to make it here. We've got, again, now it's just starting to unload the snowblowers, and we can see in our 10-hour shift that we are not able to fully unload the truck. So we don't need to even look at the simulation results to be able to understand that. So I want to use the scenario manager again, and we're going to add another scenario. Just very simply, we're going to add another fork truck. So we could, again, add as many scenarios in here as we want to and try as many different things as we want to. The software will continually run these for us, and not only that, it will run those multiple times if we wanted to allow variability to build an average for us. So that way we're going to get even more accurate results. So we'll run the 2 scenarios. As we can see in the upper left-hand corner, it's telling you which scenario is running. So now it's running scenario 2, and we can see that there are 2 fork trucks running rather than just 1. We're also seeing that the decrementing of those parts is happening a lot faster. We actually got all the tractors unloaded by the 5-hour frame, and we can now see that it's unloading all of the snowblowers for us too. So now we have confidence that we will be able to unload those. And not only that, we have all of the information in a dashboard that tells us how things are performing and what's happening. So we can see very easily in there. Now, probably we would add more accuracy to this as well, where maybe we would show things so we can show the time plot of how things are moving, but we'd also maybe want to add something like recharging time for the battery or for the fork trucks or anything like that. The whole idea of how we do this is to crawl, to walk, then to run. So we start with something very simple, and we start adding more parameters and criteria as we go to more accurately depict what's going on. So again, we have our 3D representation that's been created automatically using the factory design utilities. But we can also go in here and see things running in the 3D environment. So we can see the fork truck going down and dropping things off. And again, we can see that all run. So it makes it really easy for us to be able to portray or to communicate what our design intent is. So that was a very simple example. Let's talk to something that's a little bit more complicated. In this case, we have a warehouse that's using a lot of different things to put things away. So in this case, it's got a truck that's coming here and getting unloaded. It's using a pallet jack to unload those. The fork truck is picking those up and moving them, and then a hand fork truck is putting those away on the shelves. So we've got not only different entities that are moving things, resources that are moving things around, but we also have all the people that are involved too. You notice the truck pulled away from the building. So now basically everybody has to wait until that truck comes back. But we can see all of this information. And rather than running at a state of only 40 hours, we could be running this over 6 weeks so we can see what's going to happen there as well. So again, the whole idea is to simulate over time. So, by applying the entire solution, cost savings and design confidence can be assured not only in the installation phase, but also validation that the design will meet production output goals and will also provide financial information to support it. In all cases, we prove that our ideas are clearly actionable and they can be used over and over again for testing new scenarios in production. By applying the entire solution, cost savings and design confidence can be assured in not only the installation phase, but also validation that the design will meet production output goals with financial information to support it. So this gives us complete design confidence. If you'd like to know more, at Autodesk University, come and see us at booth 220. We have consulting staff available to answer further questions and to better understand what your need or use case would be. We have special show pricing for ProModel. There's a coupon available at the booth. Come on over and take a look. And we have reseller partners available to provide software and training. Some of these resellers are probably people that you're already buying your software from. So I'd like to thank you for your time and attention, and hopefully you will find this compelling enough to explore further the complete solution that we're offering between the Autodesk Factory Tools and ProModel AutoCAD Edition.